very attentive and I like this.
This is that cover is having this.
Yes, sir.
That is Schrodinger cat.
Yes, sir. Now, before I start my presentation, I have few objectives that I wish to achieve after my presentation, like an outline of the presentation. So, after this presentation, we are supposed to be able to define what is spin orbit coupling is, and then we should be able to explain how this spin orbit coupling or interaction is happening, from where it is originating. At the same time, we should be able to derive few expressions to solve or calculate spin orbit orbital couplings that we will see. So mainly we focus on this to try to achieve this in this presentation. Now, what is spin orbit coupling? If you look into the visual picture here, you are going to see two electrons revolving around the nucleus, which means the electrons are moving around the nucleus on a fixed path, which we call it as orbital orbit. Same like the solar system. In the center we have sun, planets revolving around the sun. So if you take the example of Earth, our Earth takes 365 days and 1/4 to make a complete revolution around the sun. Because of that, the significance is that we experience different types of seasons. Summer, winter, autumn, spring, hot, dry. Same like that. When electron revolves around the nucleus or spins around the nucleus, we know it is a particle physics that a particular charge, a small charge, when it accelerates, it is going to produce current, which is electricity. With that current, there is a development of magnetic field. So when electron revolves around the nucleus in the orbit, there is a magnetic field that we call it as angular magnetic field, or we call it as internal magnetic field. Now, if you look closely here, the electrons, they are not only revolving, they are also spinning on its own axis, clockwise and clockwise. Same like again, if you put that in the, compare with Earth. Earth not only revolving around the sun, it is also spinning, rotating. So Earth is taking 24 hours to complete one rotation. The significance is we have day and night. 12 hours day, 12 hours night. Same like that, the electrons, when they spin in its orbit, in its axis, clockwise and anti-clockwise, again there is a development of a magnetic field, which we call it as spin magnetic field. Now, because you see here, there are two types of magnetic field developed. One is internal magnetic field, or we can call like orbital magnetic field, developed by the motion of electron around the nucleus. One is electron spin magnetic field, which is because of the electron spinning clockwise and anti-clockwise. When these two magnetic fields interact together, that is called coupling. So I have a definition here. This is the book definition that we get. So you can read and see. As I explained earlier, it is the interaction between the intrinsic spin magnetic moment and the magnetic field generated by its orbital, the moment of the nucleus. So I am explaining.
One second, you just explain this coupling. Coupling, what is coupling?
So,
Is it that it is only the interaction between the spins of the two electrons, or it is the interaction of the spin of the electron along with the revolving of the in the orbital motion?
yes.
What is
So when the internal magnetic field, which means angular orbital magnetic field, which is generated by moving the electron around the nucleus, that interacts with the spin magnetic field. That is when they interact, the total change in the energy may increase or decrease. That coupling or that interaction is coupling. Now, where does it originate? From where does it get this coupling, or from where does it happen? And very simple, right? I have said earlier, it happens in the atom. Why? Because in atom, electron, they have two types of motion. One around the nucleus, one on its own axis. So because of these two, like I said earlier, there is a generation of current, and along with the current, we know that there will be obviously magnetic field. And when these two different magnetic field generated by electron spin and orbital spin. When they combine together, that is when the spin orbital coupling is happening. Just now, very important. How can we calculate spin orbit coupling or spin orbital coupling? So it's very important for us to know how to calculate. So calculation can be done in different ways. We can use Hamiltonian method. We can use general method. So first I will show the general method because I find it very important and not even for the Hamiltonian method. So sorry I could not type the equations, so I just put on the paper and then.
It's all right. No issues.
Now first thing we have to calculate internal magnetic field. We have to calculate the magnetic field which is generated by electron revolving around the nucleus. So I have drawn a diagram here. So in the center we have nucleus. Here. This is the electron. This is the orbit. And we know that electron having the radius r from the nucleus is going to move around the nucleus with the velocity v. But we cannot use electron to calculate internal magnetic field. It is mathematically difficult to calculate electron's internal magnetic field. Because electron has two types of field. Because it is going to generate internal magnetic field as well as electron itself is spinning. So it is also going to have spin magnetic field. So electron is having two magnetic field. So if you try to calculate magnetic field with the help of electron, these two magnetic field try to interfere and then it is going to make the calculation difficult. Which means in simple, we cannot calculate two variables at the same time. So we have to find one. That's why what we do, we will take the assumption by fixing this electron, by keeping the electron fixed and assuming that the nucleus is rotating around the electron. I can give you an example. When you are driving a car, if you're going to a vehicle, if you watch from outside, you see the vehicle is moving. But from inside, you see the trees are moving. Same like that. So whichever you point take, both are moving. Example, with respect to sun, Earth is rotating around the sun. But from the Earth, we see the sun is moving. But they are moving in the opposite direction. That we can use here. So electron is moving in this direction. So if we take the electron and fix it, then nucleus will move in the opposite direction. So since nucleus doesn't spin, so we can calculate the internal magnetic field using the nucleus. That's why we will use this to calculate the internal magnetic field. So we know that when charged particle, when they accelerate with some velocity, they are going to produce current. For that, we take current I here, vector here in this case. Now, when we fix the position of electron or when we take electron in the frame of rest, then we take nucleus. So, the current produced by nucleus we take like negative ZT V vector. So, this becomes our equation 1. Then we are going to use Biot-Savart law.
All of you could understand that equation 1. What is ideal?
There is R is the distance between the nucleus and the electron.
Just explain once again that first equation, ideal.
So, I is the current. How where do we get the current?
Acceleration of electron.
And then we are having little v, velocity of v. That's why we use current here. And then here we are not using I, in place of I.
That is DL, na? That is DL.
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 Vector DL. And we are using
DL for? DL for what? I mean, okay. Ideal, so okay, fine.
So this, in place of I, we are using ZT because we are using nucleus. Just then we are using Biot-Savart law here. Biot-Savart law is a fundamental of
V minus JD V.
Yes. Minus because it is moving in opposite.
Opposite.
That's right. So Biot-Savart law we know is a fundamental electromagnetic law which says that the magnetic field, that is B vector, is given by mu mode divided by 4 pi current here times R vector divided by R. Q. This is what drives our process. Which means the magnetic field generated by any current at a particular point is given by mu naught divided by 4 pi. What is this mu naught? Mu naught refers to the permeability of free space.
Permeability of space.
Yes. And then if you look into the permeability of free space with respect to light, then we get this equation. That is mu naught equals to 1 by epsilon rho c square. From this equation we get it. So epsilon naught means it is the permeability. And C here is the light constant. So we get this equation, so this becomes our equation 3, this becomes our equation 2, and what we have to do, we have to just put equation 1 and equation 3 in equation 2. So when we substitute equation 2 and 1 and 3 in equation 2, we get the magnetic field, internal magnetic field is given by negative ZT, that is the nucleus, or you can say Z atomic number, and E is the charge, velocity vector times radius vector upon 4 pi epsilon naught c square r cubed.
What is mu naught?
Mu naught, sir, it's a permeability of free space.
Permeability of free space.
Yes.
Epsilon naught?
Epsilon naught is permutative. Permutative.
Huh?
Permutative.
Permittivity of free space.
Permeability. Permeability of free space is mu naught.
No sir.
This one is
Mu,
permeability of free space. This one is permutative.
Permutative, not permittivity of free space. This is epsilon naught is permutative.
Yes.
That is not of free space.
No, not free space.
That is permittivity of this one.
Yes.
Okay, so
so DL actually the length of the conductor.
I into dl is the length of the conductor, but you told
Because
dl.
Biot-Savart's law explains that when the particular point the charge particle is moving, when the current is passing through that conductor, then the conductor's length, along the length the current will pass, and the position vector will look like this expression.
Yes. I dl, that is it. Okay. Just if you don't know, don't be there. Mu naught is equal to E 1 by epsilon naught c square, right? So 1 by c square is equal to mu naught into epsilon naught. So this equation, from where you got this equation?
Obvious.
From where you got that? No, that is fine.
Yes. But we are just converting this in terms of light.
Instead of in terms of light. Light.
Yes. So when we convert this mu naught in terms of light, then we get this equation. Or this equation, same sir.
And you convert the space in terms of light.
Yes.
Right?
Now this one is what we have to do. We have to multiply the right hand side of the equation with the mass of the electron. At the same time we divide to simplify the equation. So we multiply and divide at the same time. So the mass, the magnetic field, that is P vector is given by negative ZE mass of electron. V vector cross R vector upon 4 pi epsilon naught c square R cubed and mass. Like you see here, vector cross vector, so cross vector product is not commutative. That's why we are taking negative V vector cross R vector. So when we substitute this here, the negative sign is cancelled. So we get ZEM R vector times V vector divided by 4 pi epsilon naught c square R square n. Now if you look into this one, M times R vector cross V vector. It is nothing but it is angular moment. So in place of this, we substitute the L vector as the angular momentum, and we substitute here. So we get the magnetic field vector is given by
So nu naught is the permeability, sir, and epsilon naught is the permittivity.
Not a permeability.
Permeability. Magnetic.
So the mu naught is permittivity of space without permeability.
But medium रे ଆମେ ଯେତେବେଳେ consider କରିବା permittivity that is epsilon r.
ସେ medium ଟା ହଉଛି epsilon r, ନା epsilon naught
No.
ହଉଛି permeability of the permeability
free space.
ସେଇଟା ସେ permeable ତା ପାଖରେ question ନା. Now you got it, you are right. I mean, mu naught is permittivity.
No sir,
Of space.
permeability.
Now, epsilon naught is permeability of space.
Mu naught is permeability of free space.
Permeability of free space. Epsilon naught permittivity.
Permittivity.
Yeah.
Permittivity.
Okay.
So we get that.
Okay, and angular momentum is mass into velocity, right?
Yes.
R is also there. Mass, angular momentum is mass into velocity. Now we vector m into v.
And L equal to mvr.
Yeah.
Yes sir. Mass into
Oh,
velocity.
angular momentum. You are right.
Because the radius also there.
Momentum is mass into velocity. Yes.
Yes, sir.
But this is angular momentum. R will be there. Yes, you are correct.
That's why we substitute L as L vector, so we get Z3 L vector upon 4 pi epsilon naught C square RPM L. This is the equation 4. Now if you look here, the magnetic field is highly dependent on the angular momentum. So this is the significance of this. Now let's look into the second part. The second part is the spin orbital interaction.
You take that clock. Let me tell you guys one thing. Don't erase that with hand. Okay, why? Because that ink, that is not good. That is toxic. The smell that ink is, it's having that particles that ink is formed. That is toxic. Okay. Don't erase it by hand or some. Always use cloth because that is toxic. Sometimes that
Irritation.
use that carcinogenic, but it's not. Don't get that much scared. But that is toxic. Don't use hand. Okay, use cloth. All of you don't use hand.
Now let's look into the spin orbit interaction energy. Now when you say spin magnetic field is given by mu s vector. So mu s vector means it's talking about the spin magnetic field. Now when spin magnetic field and eternal magnetic field, when there is an interaction, there is a change in the potential energy, or you can say there is a change in energy. It may increase or decrease depending upon the spin plus bar times r. So we use delta E dash SL to denote the change in the potential energy, or change, you can say change in the energy of spin, like spin and then angular momentum. So we take this and we get the equation that the spin orbital interaction energy is given by spin magnetic field of electron minus the magnetic field of the magnetic field. That becomes equation 5. And then the spin magnetic field or mu s vector is given by negative GS. The GS is electron field spin factor, and then mu b. Mu b here refers to Bohr's megaton and magneton, and divided by h dash, which is reduced Planck constant times spin vector. So this becomes the equation 6. Now you put equation 6 in equation 5.
Phi equals to 5, there is minus. Okay, I understood S for spin and L for angular, the internal magnet. Okay, spin momentum and internal. But phi minus means minus b.
Because we are doing the change.
Change, interaction change. So minus both will be there.
Yes.
Oh, yeah, I got it. Now, you see, why there is minus symbol, can anyone explain?
Spin will be opposite to the direction of.
It is simple layman point of view. Suppose I am going this way, you are coming this way. I am going in my velocity and you are going here this same velocity. if we will interact, so my speed is velocity, my speed is also decreased and your speed is also decreased. So we will talk or whatever interaction we will do. So both is getting negative. That is a minus minus. Okay.
So when I substitute, we get here the change in the internal energy of spin orbit is given by the electron spin factor times the Gauss magneton times spin vector times your magnetic field vector divided by reduced that constant. This becomes
There is H cross.
H
Tell H cross.
H cross.
H cross.
Not H dash. H cross.
H cross. That's not H cross.
And what we do, we try to equate equation 4 and equation 7, the equation that we call earlier, equation 4. So when we equate equation 4 and equation 7 together, we get the change in the energy, spin orbit international energy is given by Z GS. So Z, you know, it can come from this GS spin factor, mu v, Gauss magneton, and spin vector and angular vector divided by 4 pi epsilon naught h cross c square r3, and this becomes our equation 8. Now in this equation 8, we substitute the value for the Gauss magneton and spin factor. So the value for spin factor is 2, magneton spin factor. Then the value for Gauss magneton is E h cross divided by 2n. So when we substitute here, we get 2 gets cancelled, h cross gets cancelled, and ultimately we get this equation where the change in the spin orbit coupling energy or international energy is given by Z squared divided by 4 pi epsilon naught m squared c squared r cubed s the spin vector dot angular vector. Now if you see this, this is the ultimate general equation. This equation 9 is the ultimate general equation to calculate the change or calculate the spin orbital energy. But since we have used nucleus to calculate this, we are calculating this by taking account of nucleus and keeping the electron at the rest or fixing the electron. When we use electron, we cannot use this equation. Because electron, it has two possibilities to spin, plus half, minus half. That's why we divide this by 2. Or simply we can add half here. So if you want to calculate energy using electrons, so this is the connected version of equation where it becomes half Z squared divided by 4 pi epsilon naught m squared c squared r cubed. Then spin vector, not angular vector. So you can also say that 2 times 2 can multiply with 8 seems like 2. So you can also write 8 pi epsilon naught m squared c squared r squared. Yes, you cannot see this also. Okay, the equation can be written in this form also. Now if you look into this equation, these are almost constant. But if you see here, the spin orbital energy, internal energy is solely depending on the product of the S dot and S vector dot L vector, angular vector. So which means the energy is depending on the spin vector and then angular vector. So we have to calculate this. So next we will calculate this.
Just wait now. So all of you got the difference between equation 9 and 10. All of you got equation 9 and 10 difference. So equation 9, you mean to say that is when the nucleus is electron is constant and nucleus is revolving. Okay. And this equation 10. So since now here the electron is moving, since nucleus is constant and electron having both the motions, spin momentum as well as angular momentum. So that you have divided by half. So plus minus, that's why this. So one more I have one. What is GS you told? GS is?
This one, sir. Electron spin factor.
Huh?
Electron spin factor.
Electron spin vector. GS value is 2. Why it is 2? Do you have idea?
Electron 2.
Two speeds.
speeds.
That's right.
Now we will try to calculate the string vector and then angular vector. So we have already studied this in our previous classes. So we know that string vector and then angular vector, if you multiply them, you will get the total angular momentum, that is J. So we have taken J vector equals to L vector dot S vector. This becomes our equation. Now if you try to multiply J vector by J vector, I forgot one equation to write this. J vector dot J vector L vector dot S vector times L vector. This is what we get. If you father
This was written for lower.
if we father 11 to x1, then we get a plus b whole square. Same things we get.
There is no plus sign. Low is the mass here. No? Actually, there is no plus sign here. No, really.
There is no plus sign.
Then here L vector S vector plus S vector dot L vector plus S vector. So here this comes here S square plus S dot S square plus 2S vector dot L vector. Now why we are taking this S vector dot L vector is
The plus sign anything multiply over. Huh? L plus S over. Huh? L plus S, it will be L plus S, right? Lower. It will be L plus S, then L plus S into L plus S, it is there, then L into L plus L into S plus S into L, S into S. If it is multiplied, J is equal to L into S, na?
J equal to L times S.
In the second equation, after 11 equation, J equal to means J into J you are doing, then LS into LS, and in the third line, if you see there is the plus sign. But in the above statement where you multiplying, there is no plus symbol.
here.
Ah.
Because we are multiplying this.
If we multiply, then using the distributive property, individually term can be multiplied to the second one. Means L will multiply with next L.
Only if J is equal to L plus S, then only it is possible. Is L plus S? No.
No.
They are also equivalent. L plus S.
No S
L
multiplied
plus
by
S.
S. What? S plus L.
The plus sign is coming now. I think it is imaginary, I guess. We cannot take it from mathematics, I guess. Because if it will be L plus S, J is equal to L plus S. Then L plus S, J into J is equal to L plus S plus L plus S. Then L into L plus L into S, S into L plus S into S. But this is not plus, right? This is so that is imaginary. I mean, it's not. I think mathematically
Book also there. Book of explains all this.
it is given. Yeah? Okay. And then why it is given? So this statement is not there.
This statement also.
Book it is there or not? It is not there.
This one.
This one.
This one is this.
It is there. So it is just types of. It's not mathematical. It's just types of interactions. We just know.
Maybe he might forgot what J equal to S plus S, not S multiplied by S.
J is equal to L plus S. J is equal to L plus S.
Just check in the Google.
Yes, sir.
A equal to
L plus S ठीक इतने देखो ना इतने वो तम तारे रेकॉर्डिंग से हाँ मेरा गड़बड़ है ना just one second L plus S
yes, N S what the
Ah.
equal to N plus S.
हाँ
But if you take L plus L, then we will modify the distance. Here is coming L.
Yes, sir. J is equal to L plus S.
L plus S ना
Then
J
here
is equal to
also,
L plus S
here also we have to
You
do
get
plus like this.
no.
you will get just
this is, you see,
You reject it after multiplying, you reject it.
so now, this is j is to L plus s. So if it is L plus s only, you will get that.
Same.
So you do it. Finally, you might get, you will get.
Yes.
You get that.
It's correct because you have to
Very good. So this is the advantage when we will discuss. Okay, this is good. So z is equal to, here you can write it. Just a minute, just a second. No. So it's fine.
Yeah.
Only plus L plus s. This is L plus s into L plus s. Then now it is fine. Now it is fine. Now you come, you will get s. Don't worry. You go ahead, you will get s.
Maybe I have just.
Yeah, no issue. That's that happens. Okay, very good.
Thank you. My weakness, your strength. Thank you for letting me know this. So ultimately, when we do so, we know that
Now you understood that L into L, LS, it is fine now.
now vector plot vector, I mean, is commutative. That's why, since I want to calculate S dot L, so I take this. Both are same. They are since they are commutative. I take in case of this, I take this and then it's here. It goes to S vector dot L vector. So when we try to calculate S vector dot L vector, bring it here. So this is the equation that we get. Then this J here. So J square minus N square minus X square divided by 2 is what we get. So this is
Here, L square, S square, that will automatically become S. So what finally you are getting?
So finally my aim is to find this. Because I have to put in the next.
Okay, just wait. Okay, by 2. Yeah, okay, fine. Now you see, there. Just, okay. You want to get S into L, that one put that one. Now you see this is correct. Why this is correct? J square is equal to L square plus S square plus 2. This is equal to L plus S square.
Whole square.
Are you getting? L square plus S square plus B square plus 2AB. A plus B whole square, N plus S square. So what is this? J or J is equal to L plus S. So this is correct. Okay, you got it? Huh? Yes. Okay, you are going to find out S into L. So that's why. Okay.
Now what we have to do then, we have to substitute the value of J, S and M. J is the proper angular moment and then S string and M is angular moment. So the value of J is given here under root of J plus I and S cross. The value of S is given under the root of S plus 1 H cross. And then L equals to under the root of L and then L plus 1 H cross. So what we have to substitute this in equation.
Sorry. Just go one slide back. Just want to see. Okay.
So we have to substitute the values.
Here you are substituting JLS value, then you will find it.
Yes.
Okay.
So here we are substituting the value. So when we substitute, we get spin vector or L vector is given by J plus I H cross square. The square here is
J plus 1, not J plus I.
J plus 1. The square here is used to so same here minus L plus 1 and then H cross square minus S plus 1 H square and H cross square divided by 2. Then you simplify this. The H square and then H cross square is common, you get this equation 30. And then you put equation 30.
It was 2 in the 2 or root 2? Back, go back once. Then it will be 4, na? Go next slide.
I remove the square.
No, that is fine. But 2 is there, na? It will be 4, na?
No, sir.
No, just 2. Go back.
You see, this is.
I'm just applying the gravity as this is
No,
all.
that is fine. Oh, this okay. Okay. Yeah. Okay.
How, sir, how the 2 divided is there?
No, 2 divided because SL is 2SL is equal to this much, na? So SL is equal by 2.
You just replace
And
A
J
and
square minus L square minus S square by 2. Can SL का से भाग करा चाहते ना? ठीक है, that's fine. बुझ पा तो? हाँ?
So ultimately, if you put equation 13 in equation 10, we substitute and then we get a change in the spin moment coupling energy is given by Z squared divided by 8 pi epsilon naught m squared c squared r squared times from here we substitute here that is h cos square and then the value of j s and l j plus 1 minus l plus 1 and s plus 1 divided by 2 here. And then if you simplify it further, we get this change in the energy of spin orbit. Interaction of the coupling is given by Z e square h square, h cos square divided by 16 pi epsilon naught m square c square r cube, and then j plus 1 minus l plus 1 minus s plus 1 is what we get. So this is the ultimate equation that we get to calculate the spin orbit interactions.
Okay.
Yes, sir.
Go.
And now let's try to look into how can we use Hamiltonian approach. Everything is same, but basically same. Only thing is there is a change in the energy, how we denote the energy. In the previous derivation, we used delta E SL to show the change in the spin and orbital value. But here we just use Hamiltonian H. So that is the only difference. But here the derivations are much more shorter. So I just taken from the book and cut basically. This one.
20.
So as we talked earlier that we are going to use photon or the nucleus relative to calculate the magnetic field. So here the magnetic field given by the nucleus and its E vector. Then there is a del V, a change in the velocity because it is moving opposite to the electrons nucleus. That's why. So ultimately we get the same equation that we have on earlier, that is Z divided by 4 pi epsilon naught r vector. And just adding the right this one. Then second one, I have explained that the electron is taken as rest. So by taking that account, what we have known is, we know that the magnetic field, that is B vector, is given by minus 1 by c square velocity V vector times E vector. Now you substitute this value of E from here. This one will bring it and substitute here. When you substitute E, then we get magnetic energy or electromagnetic energy equals to minus 1 by c square V vector cross Z divided by 4 pi epsilon naught r cube r vector. And then if you further simplify, we get magnetic field, that is V vector equals to minus Z divided by 4 pi epsilon naught E square r cube V vector cross r vector. That's r vector. Now similar to the previous presentation, we just replace V vector times r vector with negative r vector times V vector because I just already explained it because they are not commutative. So we put this negative here. So when we replace this, we get the same equation as we got in the earlier presentation. That is the magnetic field is given by Z divided by 4 pi epsilon note c square r cube vector r vector times d vector. Then we have to bring angular momentum and then substitute here. So we know angular momentum L that is given by m r vector times d vector. So that we substitute here in this set of equation. So we get d vector, or we call it as magnetic internal magnetic field, is given by Za divided by 4 pi epsilon m c square r cube angular vector. Same line. Now we are going to introduce the electron spin magnetic moment, which is denoted by mu vector s. And here you can see this is the electron spin factor, Gs. This one, in earlier slide, this is nothing but it is more magnetron. Here they have directly given the value. They are just inserting the value here times spin vector. So by substituting the value for spin factor, that is 2. So 2 gets cancelled, and then we get final equation this. That is mu vector s equals to negative e divided by m spin vector. Then we use the Hamiltonian interaction. So spin orbital. Only we just introduce Hamiltonian interaction. So we know that Hamiltonian is given by its product between the spin magnetic momentum or spin magnetic field and the orbital magnetic field or internal magnetic field. The same equation. And when we substitute here the value for spin magnet and then magnetic momentum and then internal magnetic momentum, we ultimately get this equation. Now the final equation that we get is Hamiltonian for spin orbital coupling. HSO means Hamiltonian for spin orbital coupling is given by Z squared divided by 4 pi epsilon naught E squared C squared R cube and S vector. Seems L vector dot S vector. So here, like I said earlier, since it is calculated based on the nucleus by keeping the electron at rest, if you try to calculate energy in the head of electron, it will be much more higher. That's why when we use Hamiltonian, the connection is called Thomas position connection, or they give a name like Thomas connection or Thomas position. It's nothing but they just divide it with 2. Same number, but the name is given difference. So when we divide it by 2 or when we put half here, we get the ultimate equation, that is the Hamiltonian spin orbital coupling is given by half and Ze squared divided by 4 pi epsilon naught m square c square r square angular momentum vector or spin vector. So this is the ultimate that we get that we can use to calculate the spin orbital coupling with the help of Hamiltonian. Everything is same, only thing is the how we determine the energy is different. In the general we use delta E, but here Hamiltonian we just use energy E. That is the
What is R here? R.
Yes, sir. This one, sir. It's a radius.
Radius of what?
Radius.
Orbital angular motion on the orbit.
Yes, sir.
Radius of orbit. How much you will take? See, mass is the mass of electron or proton?
Electrons. So this is the last. It's like. So if you like to calculate the total angular momentum, same equation. Same equation. Same equation. Like earlier, we know that angular Maybe I made a mistake. I'm sure so. So here the angular momentum is given by J vector equals to F vector plus S vector. So if you substitute, you get the same equation like before. So this is the overall equation to calculate the electron and spin orbital. And this is the cat that I have shown you. In the beginning, the cat was alive, active. At the end of quantum chemistry, the cat is dead.
So you think that we are cats? Who is cat? We are cats or you are cats? Just go back 1 second. Go back. E cat of electron is permittivity of this space, epsilon 0 mass minus speed of light. Here there is no R term. R is radius of the orbit. And the nucleus. Okay, next let us see. Now the cat has
At the beginning, the cat was looking, but at the end,
I think he had lot of coupling here and there. Finally, is pen. Not dead, pen. Very nice presentation. So now, actually, you are a teacher. You are a teacher.